Okay, this video we're going to talk about drawing Bohr models and Lewis dot diagrams. They're the two different ways that we represent atoms in physical science. So basically, Bohr model is the more complicated of the two. In the Bohr model, we draw the nucleus as the inner circle. So we would have the nucleus here. We're going to include how many protons it has, how many neutrons it has, and then we draw the electrons as concentric rings around the nucleus. So this first one holds 2 electrons. The second one and third one both hold 8. We only have to draw Bohr models up to the first 18, so we don't care how much a fourth one would hold. It also holds 8. So, with the Lewis dot diagram, we just represent the atom by drawing its symbol. And then we draw the valence electrons. So the valence electrons are those outermost electrons. And we just draw them as dots. They get situated in 4 places around the symbol, left, right, top, bottom. And then we pair them up once we've got one on every side. They start to pair up until we get to 8. We can't draw more than 8 valence electrons around any one symbol, so don't try drawing 19 or 18. When we talk about the Bohr model, or if we're going to actually draw a Bohr model, let's say we're doing it for beryllium, we start out by figuring out how many protons there are. So that's the atomic number, right? So we do 4 protons. The average atomic mass of beryllium is 9.012, so we'd round that to 9. 9 minus 4 is, so we'd have 5 neutrons. That's my nucleus. Going around that, I'm going to have my first ring. Since there's 4 protons, that means there's going to be 4 electrons, but this first ring can only hold 2, so that one's full. Second ring is going to hold the other 2. To do the Lewis dot diagram, it's a whole lot easier. We just take the symbol, it's Be, and then we look at what our valence electrons are here for the Bohr model. So that's this one and this one. I know these are valence because that's the outside. The outermost orbit is always going to be where we find our valence electrons. So this one would have 2 valence electrons. Easy peasy. If we do magnesium, so magnesium is in the same group as beryllium, just one period down. The Bohr model is going to look very similar. So we're going to do 12 protons. 24 minus 12 is going to be 12 neutrons. My first orbit, it's going to be, that orbit's kind of touching the nucleus. Gross. You don't want that to happen. So the first one is going to get 2. The second one, like we said before, fills up with 8. So we would do 1, 2, 3, 4, and then I kind of pair these up. If I pair them up, it's a whole lot easier for me to see 4 groups of 2 than it is for me to count to 8. Then this third ring. So since magnesium is in period 3, I can tell it's in period 3 because when I look at my periodic table, period 1, period 2, period 3, there's magnesium. So I've got 10 I've drawn, there's the next 2. So magnesium and beryllium both have 2 valence electrons. So when I do the Lewis dot diagram, it would be Mg and I would get 2 there.